Okay, so in this particular case, we've got oxygen reacting with ammonia to produce nitric oxide and water. And we've been asked to calculate the volume that's going to be occupied by the nitric oxide that's produced, and specifically at room temperature and pressure. So in order to try and actually calculate the volume occupied, what I'm going to want to try and work out is the amount of substance of the nitric oxide, right? But it's not a direct process. Based on the data we do have in the question, it makes sense to try and work it out from the oxygen, right? If in effect the oxygen is the limiting reagent in this reaction because the NH3 is in excess, right? So really what's going to determine the amount of nitric oxide that's produced in this reaction is going to be the amount of oxygen, right? And so what I'm going to use is the equation that relates mass, moles, and molar mass. So the number of moles is equal to the mass divided by the molar mass, right? So I'm going to use this equation to work out the amount of substance of the oxygen, right? So this is for oxygen that I'm using this equation initially. And so we know that the mass is actually given in the question, right? So that's going to be 16.84 grams. But the molar mass, we have not been given that in the question, but what we do have is the formula for oxygen. So we can use the periodic table to work out what the molar mass is going to be, right? So for oxygen, as you can see here, the relative atomic mass is 16. So simply what we need to do is the MR of O2 is going to be 16 multiplied by the frequency of occurrence, which is 2. And that's going to give us the molar mass, which is going to be 32, right? And that's going to be in grams per mole. Okay. Now that 32 we can say, okay, that's going to be 32 grams per mole, right? And more specifically, now that we've got those values, we need to plug that in, run a calculation to see what value we get. This is going to tell us the amount of substance for the oxygen. So if you do that calculation, which is 16.84 divided by, so just to clarify, that's the number of moles of oxygen O2, 16.84 divided by 32, which is going to be 0.52625, right? And that's going to be in moles, right? Now that we've got that value, what we need to really do is, I'm going to look at the balanced equation, right? So if we look at this balanced equation, we've got the oxygen, right? So it's 5O2, and we've got the nitric oxide. So what this tells us is that for every, so I'm going to set this up as a ratio, so the number of moles of oxygen compared as a ratio to the number of moles of NO, right? So what that equation tells us is that for every 5 moles of oxygen, we're going to have 4 moles of nitric oxide, right? Now what I want to try and do as the first step is I want to get the left hand side here, so the oxygen side, I want to get this number to be 1, right? So in order to get it to 1, I need to divide it by, of course, 5, right? So divided by 5, and because I'm doing this to one side, because it's a ratio, I need to do the same thing to the other side, right? So divided by 5, and what we get is we get the 1 on this side, but that's going to be in a ratio of 4/5, right? Okay. And what does that tell us? Well, what this in effect tells us is that for every 1 mole of oxygen, we're going to have 4/5 moles of of nitric oxide. And what this in effect tells us is that the number of moles of nitric oxide is equal to 4/5 multiplied by the number of moles of oxygen, right? So that's it in a represented in a more formulaic kind of sense. But we have that value, right? So we have that value here, the 0.52625. So number of moles of NO is equal to 4/5 multiplied by 0.52625, right? And so if you do work that out, what you find is you get 0.421, right? 0.421 moles. Okay, so this is the number of moles of the nitric oxide. Remember, what we've actually been asked to work out is the volume occupied by the nitric oxide. So there's still some more work to do. What we're told in the question is that we're asked what is the volume specifically at room temperature and pressure, right? So we're asked what is the volume at room temperature and pressure, and we're told that at room temperature and pressure, a given 1 mole of any gas will occupy 24 decimeters cubed. What that tells us is that for any given molar amount that we've calculated for in moles for our gas, specifically at room temperature and pressure, if we multiply that value by 24, we're going to get the volume occupied. So in this case, we do have a value. Let's multiply it by 24 to get the volume occupied, right? So the volume of, in this case, is NO that we're looking at, right, equals 24 multiplied by 0.421, right? And that's going to give us 10.104. And that's going to be in decimeters cubed. What we need to remember is we've been asked to give our answer to 2 decimal places as a maximum, right? So here. So in this case, if we do round it, if you round it initially to 2 decimal places, you find that you get 10.10, right? Because we have to round that down. But this can be rounded further just because, I mean, ultimately, and when I say rounded, I don't mean, what I mean is we can drop the 0 because the question specifically says a maximum of 2 decimal places rather than saying 2 decimal places. The 0 is a bit redundant in some sense, right? So given we do not have to be give our answer to exactly 2 decimal places, we can just write equals 10.1 and then decimeters cubed, right? So this would be to 1 decimal place, which is kind of within basically within what the question is specifically asking us to do. So this is going to be what the volume occupied is in this case.